This is a short video about fatty acids. Fatty acids are the most basic unit of triglycerides and phospholipids. Fatty acids are basically long chains of carbon with hydrogens hanging off of each side. The bonds between the carbon atoms determine the type of fatty acid. There are lots of fatty acids. Over 20 different fatty acids are used in human nutrition. And those fatty acids can vary by their length, whether the carbons have double or single bonds between them, and the total number of double bonds between the carbon atoms. There are several different types of fatty acids: polyunsaturated, monounsaturated, and saturated fatty acids. And we're going to start by talking about the saturated fatty acids. Saturated fatty acids have only single bonds between the carbon atoms. Most of the fatty acids that are saturated, or I should say better, most of the fats that have several saturated fatty acids in them are solid at room temperature. Butter and lard are great examples. Coconut oil and palm oil are exceptions to the saturated fatty acid rules, since they are both liquid at room temperature. To try to illustrate saturated fatty acids better, I'm going to draw one for you. So saturated fatty acids are basically long chains of carbon atoms. So I'm going to draw some carbon atoms across here. And I drew 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms because that fit nicely. In real life, probably about 18, but 18 won't fit on here. One end of a fatty acid looks like this. Okay, that's O for oxygen, C for carbon, H for hydrogen. Between the carbon and the oxygen, you're going to see a single bond. Between the carbon and the oxygen on the top, you see a double bond. Okay? But that double bond doesn't relate to whether this is saturated or not, because that's not between the carbon atoms. I'm going to draw, first let me show you the other end of a fatty acid. Other end of the fatty acids always looks like this. Okay. I'm going to draw single bonds between the carbon atoms, like this. By definition, a carbon has to have 4 little lines around it. It has to do with the electrons and way beyond this class, but you've got to have 4 lines. So look, if we look at the very first carbon, we have 1, 2, 3, 4 lines, but these carbons only have 2 lines, one on each side. So I'm going to put hydrogens in. So now everything will have 4 lines around every C, or every carbon. Okay, this fatty acid is saturated with hydrogens. It has only single bonds between the carbons, and it is saturated with the hydrogens. So we call this a saturated fatty acid. Okay, we contrast that with a monounsaturated fatty acid. Monounsaturated fatty acids have one bond between the carbon atoms. Olive oil and canola oil are good examples of MUFAs, monounsaturated fatty acids. And I'm going to draw one of those for you in just a second. I'm going to draw the same 8, well, it won't be exactly the same 8 because I'm drawing them again, but we're going to have 8 carbons across the screen. 1, 2, 3, 4, 5, 6, 7, 8. And the same beginning and the same end. But this time I'm going to put a double bond between two of the carbon atoms. I'm putting the double bond right there because I feel like putting it right there. In nature, it really makes a difference where the first double bond is. For illustration purposes, it doesn't really matter. So I'm going to put single bonds in everywhere else. Remember, this is a monounsaturated fatty acid. One point, that one little point, has a double bond. Everything else will look very similar. So we have this one spot here that is not saturated. Remember, the carbons have 4 lines because we have a double bond, but there's not hydrogens on the bottom. Okay? So we can contrast that with a polyunsaturated fatty acid, which contains 2 or more double bonds between the carbons. Safflower, sunflower, and corn oil have a lot of PUFAs in them. So we're going to draw that one. And we'll do the same 8 carbons. Two, 3, 4, 5, 6, 7, 8. The same beginning. The same end. And I'm going to put a couple double bonds. Okay. It could have more double bonds, and I just randomly selected where to put double bonds. Everywhere else I'm going to put a single bond, and I'm going to fill in with hydrogens. Okay. You'll see several places that do not have hydrogens on the bottom, and every carbon should have 4 little lines around it. 1, 2, 3, 4. 1, 2, 3, 4. So that all the carbons have adequate bonds around them. Okay, I've been drawing these as straight lines because it's easier to see if they're straight lines, but the book doesn't do them as straight lines. The book shows them as slanted lines because in reality that's where they are. In nature, that's the way they exist. So I want you to realize that my straight lines are really this that they show right here. Okay, that part right there, that's that straight line that I've been showing. And you can see all of these have single bonds. There's one bond in every spot. So it is a saturated fatty acid. Okay. And figure 5.2 from the book shows you that every time there's a double bond, there's a bend in the fatty acid chain. Okay. So here's a double bond, and there is a bend there because of the structure.